So a few months back, I was seeing videos addressing where you have a square root inside of a square root and trying to simplify that so that you don't have a nested square root. And there was very little explanation. It's not some trick. There's a reason why it works. For example, in this question, if you square the square root of 5 plus the square root of 24, then you have only a single square root over the 24. Is there something that we could square where you don't have a square root inside of a square root and you would only have a single square root? And the answer to that, fortunately, is yes. Square the quantity square root of a plus square root of b, and you get a plus b plus 2 times the square root of a times b. So let's set a plus b equal to 5, and 2 times the square root of ab equal to the square root of 24. And we're going to solve this system of equations. We're going to put this all in terms of a, though, by first subtracting a from both sides to isolate b in the first equation. And at the same time, let's square both sides of the second equation so that we get that 4ab is equal to 24. In other words, ab is equal to 6. Substitute in that b is equal to 5 minus a. Distribute the a, and we come up with a quadratic equation in terms of a. Let's add a squared and subtract 5a from both sides so that we have a squared minus 5a plus 6 equals 0. I picked some nice numbers here to demonstrate what's going on, but this can be applied to more difficult examples as well. This one is factorable. Negative 2 times negative 3 is equal to positive 6, and negative 2 plus negative 3 is equal to negative 5. Since we have a coefficient of 1 in front of a squared, that gives us our factorization of the quadratic. So apply the zero factor property, set each factor equal to 0. Now we have two linear equations and solve for a. Now really, you might think that this is going to give us two cases. It's not. If a is 2, then it's b that's 3. Switch it around. If it's a that's 3, then it's b that is 2. But we're really looking at the same situation. In other words, we have something that's symmetric. And that shows us that the square root of the quantity 5 plus square root of 24 is equal to square root of 2 plus square root of 3. And if you're wondering where something like this might show up, you could be solving a fourth degree polynomial equation like this one. You could also call that a quartic equation. If I add 24 to both sides and solve that by completing the square, then the quantity x squared minus 5 is equal to plus or minus the square root of 24. And so x squared is equal to 5 plus or minus square root of 24. Now take the square root of both sides again, so that x is equal to plus or minus the quantity 5 plus or minus the square root of 24. That's going to give us four solutions, one of them being the one we just simplified. And without going into all of the details here, you could show similarly the rest of them what the solutions are. Square root of 3 minus square root of 2, square root of 3 plus square root of 2, the one we just saw, negative square root of 3 plus square root of 2, or negative square root of 3 minus square root of 2. Hope this has helped giving some explanation to the several examples I was seeing on YouTube. Not a lot of explanation was given, and now we see some backup for it. Hope this helps.